So, good afternoon, all, and welcome to the another session of Structural Analysis 2. I can see people are joining fast, so let them join and also start entering your detail in the chat box so that we can go for the attendance. So, friends, we have been discussing numerical exercises on how to apply the energy principles in the structure analysis, right? That is what our topic of interest, and in that line we have reached to the 15th lecture of this series, and today again we'll go for some rigorous. I would like to show you how rigorous it can be, like how lengthy it can be intentionally, because we started one numerical in the last session, and I just want to show you to what extent you need to work on that, because yesterday I solved it for you, exclusively for you, so that I would it would be interesting for you to notice, and some of the solutions I'll be showing to you directly, because it's difficult to write long equations in this medium. So I have captured the photograph of my own handwriting, and I would like to share it with you today, and then we will be directly selecting the important steps from this numerical solution, and would like to show you how to carry out the complete analysis of the structure. So these are the old images. I'm just hovering over there, and you can see that we have completed most of the varieties with energy principle number one, which was dedicated for the calculation of the slope and deflection at various points. But then we started discussion on energy principle number two, which is dedicated for calculation of the reactions and develop the shear force and bending moment diagrams in the structure. So again, uh, I think from this point we started, right? We started with the discussion, and here you can see we have kept the redundant. It is necessary to identify a redundant in the given system, and that inspires us how we can uh, again progress with the calculation of the partial derivative of the total energy stored in form of the generalized moment equation, and how to take that partial derivative with respect to the respective force which causing that deformation. So this was the numerical we started in the last session, and you can see that we have, why I selected this, because I just wanted to show you that how versatile it is, how effective the method it is. If you have one more support here, you can even go for the third option of the redundant. You can also select that particular support as redundant, because otherwise it is very difficult to calculate the reactions even in the form of the simple vertical reaction. You have three vertical reaction, one at Va, second is Vb, and third is at Vc here, as you can see in this case. So it is next to impossible to use first fundamental principles and equilibrium conditions and to obtain these reactions, right? So that's why the importance of second energy principle is very high as far as the flexibility of calculation of the required reactions are concerned. Before we move ahead and go for the solution, I would like to raise a question over here, and it is open for all to raise their hand. My question is, there are three vertical reactions. Listen carefully the question. There are three vertical reactions expected, one at Va. However, let me go to the screen sharing once again so that I can open this pen function. Okay. So according to this condition, let me go to the red color for a while. Let me put one more reaction here in terms of VA. So total are VA, VB and VC. Right. These are the vertical reaction expected. And in addition, we have one more expected reaction in terms of friction moment, MA. Right. So my question is, first I have two questions. First question is, out of this three reaction, which will be maximum and which will be minimum and why? So you need to answer this question first. My question again, I'm repeating, and you are free to raise your hand if you know the answer. Uh, it is a qualitative analysis. I'm not asking, or I'm not going to ask the numerical solution, which is I just want to share with you within the next slide. But first, I would like to ask you in general that qualitatively, proportionally, which reaction will be maximum reaction? Can anybody would like to discuss over here? Raise your hand. Come on, you can jump in and don't hesitate. If you are incorrect, you will get corrected. Don't worry. So just try to answer the question. My question is very simple. Out of these three vertical reactions, which vertical reaction will be maximum and which will be minimum and why? If you avoid why, just tell me according to you which reaction will be maximum at least. VA will be maximum, VB will be maximum, or VC will be maximum. You can have a glance on this loading conditions. Here it is 50 kilonewton, which is large load. Here you have 20 kilonewton per running meter. So now you can use your own logic, being a structural engineer now, being a student of, yes, we have Stephen with us. So Stephen, tell us what you feel.
Because I think personally, I think VB is going to have the maximum reaction due to the fact that it's being affected by the UGL and point load.
Very good. So you want to say that VB is going to be the largest one, right?
Yes, sir.
And which reason you provided? What is your support comments?
The reason is because if you look at the effect of the point load in the UGL, they are directly related to the point load for B, which implies that it has high chance of it experiencing the highest reaction because of the two actions of the point load in the UGL.
Very good, Stephen. So you are perfectly right. You are correct, and your logic is also correct. So thank you for this discussion. So according to the answer which I have received, you can mute yourself, Stephen, now. And okay, so as he rightly said, when you start looking at to the structural loading conditions, why it is important to discuss like this, why I'm not starting calculation, because only calculation will not help you. You have to develop your own insight on the, as a structural engineer you should also understand this scenario. Let me minimize this and let me erase and create some space for further discussion. It is an interesting point which I would like to discuss with all of you. See here, if you minutely observe what is after all our structure look like. Let us say this is our beam, this is your VB, right? This is your VC, okay, and here you have VA. Okay. So now, see, understand. If you want to obtain the understanding that which reaction should be maximum, you should primarily look to the loading condition first of all. So here, if you divide this load in two parts, equal parts, here half of this load, total UDL, that is, let us say 120. So at least 60 will go here, right? And at least 60 will again go here. I'm just giving you a qualitative analysis. Please understand, we are not working exact solution. We are just qualitatively calculating, right? So at least by logic, half of the load will transfer to the support VB and half will be transferred to VC. Agree? Now, at least you can confirm that there is another load which is 50 over here. So at least, even if I assume that this is simply supported beam, at least half of this will come here. So naturally, the reaction of VB will be greater than VC, definitely, because only one load which is existing for VC, which is half of the load. But here you have doubling of the load, at least some load will get additionally added to this VB in addition to this 60. So it is quite logical to think about it. Similarly, when you compare the same scenario with VA, half of the load, let us say of 50, will directly get transferred to VA. Even in that condition also, the reaction at VB will be anyways larger than VA. So one thing is confirmed, that the reaction at VB will be largest reaction. Or if it doesn't come in that way, then you should have a question in your mind that you have made some mistake in the calculation. So be confirm, be sure, and I would advise all of you that you should have a practice of like this, that how you can, qualitatively analyze the structure before you actually start getting into the numerical steps, because numerical steps are just the confirmation of the concepts. This is what we are, more importantly, we are doing the concept development. So this is more important discussion, right? So everybody will agree with this logic that we have applied. So same logic you should apply in all the similar or any structural analysis problem. First of all, don't start simply writing the steps in solution. First of all, have a glance on the entire structure, understand the loading condition, and also understand the distribution path and proportions. It will help you to confirm your numerical answer on a later stage, because you can't imagine that what will be the length of the equations that we are going to expand in next few slides, which I have already done. It took me nearly 25 to 30 minutes to complete the numerical on my own, right? So you can very well understand that without making a single mistake, it is a huge task to carry out the calculation. Okay, so next question was, how many moments I should be getting in this? And before that, let me answer the question. This was the maximum value, and VA will be the minimum value. Now, can you tell me why it is like that? Why VA will be the minimum reaction, and why VB is done, why maximum is done, why minimum is VA? I'm giving you the answer that VA is minimum, but you have to explain me what is the reason. Reason is very simple if you think about it. Stephen, you already answered, so I'm just waiting for somebody else to answer to this question. I appreciate your preparedness, but at the same time, let's give chance to somebody else. Uh, Thank you for understanding this point. Anyone would like to? Otherwise, we'll come back to Stephen. But out of the other people, those who have joined this session, please answer this question: why VA should be minimum? Very simple answer. Very simple answer. If you follow the same logic, you will get your answer. Anyone else? Anyone from the class who would like to answer? Come on, make it fast. We don't have time. You know, just come up with your answer. Anyone? Henry. Henry is there. Yes, Henry.
Yeah, so I think it's because of less load is acting on the side of VA, so
That's
the
it.
reaction will be less.
That's it. That's it. See, the amount of load which is acting at VC. See, VB is now out of question. All of us are agree. VB is out of question because we know that it is maximum. Now the question is regarding VC and VA only. So out of them, you can see that the larger load is on the VC side. So definitely the reaction which is at VC which is going to take place is large. Anyway, so least will be VA. There is no doubt about it. So you see how wonderful it is that if you start applying the basic logic without any step, we don't need any formula and this and that, but at least you can know that you come to know that what is the intensity of the reaction in a particular loading condition. Now instead of this, now if I would have added this UDL in addition to this, definitely VA would have been larger than we see in that case, but still the VB will be the largest one, right? Now my another question, I know that I'm taking little more time, but it is interesting to discuss over here like this, that can you tell me how many moments, total moments, I'm supposed to receive in this entire given structure? The given structure is comprising the supporting cantilevers having two supports. Okay, so complete structure we are right now discussing. And my question is, how many total number of significant moments I should be receiving in this structure? And where would be the locations? Where would be the locations? The first answer is in front of you, that you can definitely receive one moment at the support. There is no doubt about it. But what about other moments? How many other moments I'm supposed to receive? The answer is again very simple. If you apply the same basic logic, basic understanding of structural analysis, you'll get your answers. Let it be wrong, you just share your views with me very quickly, very fast. Somebody is writing something, but I would appreciate that if you can raise your hand in the chat box, I mean this box, I can unmute yourself. Don't hesitate in communicating with teachers, with your colleagues. If you know something, just share it. No problem at all. Let it be wrong. Ultimately, what will happen? You'll come to know what is right thing, and who knows, you will be right also. So there is nothing wrong in taking a chance. So I need some new voice now. Anyone would like to discuss on this? How many total number of moments with their location in this problem? One is already there, MA. What are the other moments I should expect? And where should be the location? Quickly, quickly, make it fast. Somebody, at least one hand should be there with yellow symbol. Raise your hand, please. Yes, Darsha, okay. Uh, Unmute yourself.
Sir, I think at B support.
Yes, okay, you are right. Then, which are the other possible locations to receive moments other than B? You are completely right that at B you will be getting one moment definitely. So what about what do you think about spans? Span A to B and span B to C. Should we have any moment? What do you think? Yes or no? At least you can say.
Sir, at C, the summation of moment will be 0.
Yes, of course. You won't get any moment at zero at C. That is again perfect. What about this and this midpoints? Should we expect any moment over there?
No, sir.
Okay. The answer is partially correct, partially wrong. The answer is we can definitely have some span moments, right? It is just like the fixed and beam. If let me explain you, right? In this case, what we used to do, we used to calculate end moments and the span moments, right? Like this. So you cannot avoid span moments in this case. So definitely we will be receiving some span moments at point D and point middle point, or somewhere where the point of contraflexure takes place in this structure. So in total, it was a good try, Darsha. However, we have total number of moments. Support moments are two only, one at B and one at A, and span moments are another two moments that we can expect over here. Significant moments I'm talking about. And the third moment at the support will be 0 because it is the last support, and it is also not fixed. It is simple support. So there is no question of moment at all. So now friends, without any delay, let me show you this work. Okay, you can see that how tremendous it is, how lengthy calculations are there involved in this calculation. So first I did the same practice, like you can see here. If it is if you can see it in your gadgets, you can see that I have divided the beam in 2 and 3 components, C to B, B to D, and D to A, and then I developed individual equations. That's what we did in the last class. Then I took the partial derivative one by one, right? And then I started calculating everything. It was a Herculean task. So you can see that it's not possible for us to cover it into the regular writing and all, because we have to keep changing the slide, and we have limited space also in this slide. So I that's why I started working like this, and I thought that I should share this work with you so that you can come to know how rigorous it is. And that's why I have not asked you to calculate it online, so it will definitely take more time. Do not forget to mention the right limits in your segments. If you miss it, definitely it will create a lot of problem, right? So then I started with first deflection at point C. So it ended over here with this equation. You can see here the first equation is calculated here. So it is 914. The same data is there, so I'm just giving you the broader view of this equation. 914.66 time VC plus, here you can see that 362.66 VB equals to 80,000. That means 80625.66. Right? So this is the equation, first equation that we have obtained from the calculation by putting the value of, I need to confirm it. I used to put fingers on all the terms which were containing VC values. You can see I have given numbers also, so that I don't forget them. This is the pattern that you can also follow in the examination, because in exam you are already tensed a little bit and your time is short always. So have a practice some kind of large numericals. First of all, you should try to minimize the numbers of the values, right? So this is how you can obtain your first equation. Then I went for delta B. So that is the second equation, where I will be taking these value into the account, where you can see here for each last segment I have worked out for delta VB also. So first term becomes 0, so that's a good news for us. So that reduces some amount of length of this numerical. So only 2 I need to treat for particular multiplication. So relatively delta B calculation was relatively less complex. So you can see here I started with delta B, and here I have placed them segment wise. First segment is 0 to 4, second segment is also 0 to 4. And while you are expanding the terms, if you wish, I will share this solution with you, so that on your own pace you can go through the details, you can compare your own work. So I'll be sharing the PDF with you. So only the solution I'm talking about, so that you can go through into the detail how we can expand this multiplication of one bracket with the another bracket. That is also carefully to be done. So this is what is the simplified form of this two brackets multiplication. And likewise, if you keep doing the numerical on and on, at some point you reach to the final destination of your second equation. So I'm just highlighting the second equation again. It is 362.66 VC plus 170.66 VB equals to 34,666.67. That is your second equation. Now since you have two equations, the intention of mine taking this numerical in discussion was, I just wanted to show you how we can solve problem containing two unknown reactions. So you will not be getting a direct answer. You have to solve the two equations by method of elimination of the equations, popular mathematical uh, operation you can see here, which I have done here. 914.66 VC plus 362.66 VB equals to 80,626.66. And the second equation just now we have obtained for delta B is 362.66 VC, 170.66 VB equals to 34,666.67. Now, if I multiply equation number 2 by this term 2.125, and if I use it as negative term, it will give me the chance to cancel this VB, right? So what I did is I just multiplied equation number 2 with this value negative 2.125, right? So if I multiply the equation number 2 with this value, positive term becomes negative. So that is how we can eliminate this VB term out of this, right? And eventually we can get our VC value first like this. So it is 144 because 914.66 minus 770.6525. I have worked it little precisely so that we get good results. So out of this we can get the VC value, like 144 VC equals to 6959.99. So you will be getting your first answer in terms of VC, that is 48.33 kilonewton. So this method should be used when you have more than one unknown as a redundant in your system. For example, if I take this example as further one step ahead. So let us say this is A, this is B, this is C, and this is D. Irrespective to whatever is the loading condition, doesn't matter. So you have to go for this segments, segment number 1, 2, and 3. But then you have to select this all as redundant, VC, VD, and VB. Okay, and you can have one more equation out of this. So you can go in a setup, like first you try to solve VB and VC, or you can try to solve VC and VD, and at least you should have one unknown to be known to be used in the other equation, and then on you can carry on with the calculations. So I think this is worth exploring. I mean, experience for you and numerical for you. So here I have obtained VC value as 48.33 kilonewton, and then I used it in the equation number 2 again to obtain VB value. So VB value has come up with 100.429, which is the largest value out of all the three values. Again, using sigma V equals to 0, you can see here I have obtained VA value, which is to be minimum as 21.24 kilonewton. So this is how I have shown all the reactions at their appropriate location, and as Stephen has said, the maximum reaction is at VB. You can see here it is 100.43, that is largest. Second largest is at C, and third largest, I mean smallest, is 21.24. So this is how we have obtained all the necessary vertical reactions required for this system. Now, this numerical doesn't end over here, because still you need to find out bending moments at various locations so that you can completely draw the shear force diagram as well as bending moment diagram. Now, before we discuss on bending moment diagram, how to generate it, take a look on this structure once again. You can see that there are some span loading. Here it is 50, and this is the UDL, right? And this is the beam itself, right? So it is quite natural that we will be having some critical sections of maximum span moment in this loading, right? So we need to find out bending moment at all important locations. Now it is by default that we have to calculate MA, that is fixed end moment. You can expect some internal moment at support B, because it is trying to balance portion A to B and B to C. So there will be some unbalanced moment which is available at joint B. As you know, the characteristic of sort of continuity of these two beams together. And it is very well known that since the last support is a simple support, we cannot expect any moment, so it will be zero. But however, since you have UDL, definitely you will be having some maximum sagging moment in this span. So there is a combination of hogging and sagging throughout the beam. So at point A, you have hogging moment. At B, again, you will be having some hogging moment. And within the span A and B and C, you will be having some sagging moment also. So sagging moments we will be showing above the line. Hogging moment will be showing below the line. So likewise, we can now start calculating moments one by one. So here again I have worked it out for you, but the figures may not be too visible for you. So I just started with calculating moments about point C so that I can include moment at B. So the steps are very simple. So let me draw a figure over here, just showing you the way of calculating it. Here we have three reactions that we have worked out successfully. Right, UDL is there, point load is there, moment, reactive moment is also there. This is A, this is VB. Let me write down the values also, and VC. Right, this is 20 and this is 50. Right, so let me once again confirm the values for all the reactions here. VA is 21.24, this is 100.43, and here it is 48.33. Now you can come into the action. I want you to answer this question. Give me the value of MA. Who will give me the value of MA? Take your time, 2-3 minutes from now, and you can respond to this question. Give me a value of MA out of this. Everything is sufficient, everything is well tuned. You just need to give me the answer of MA here. So start working on that, and once you are done, raise your hand. Simple. Use your fundamental equilibrium equation, sigma V, sigma M, sigma H. I don't know which equation will be useful for you in this case to obtain moment. So of course, since it is moment, so use this. That is my tip to all of you. That is my clue to all of you. Sigma M equals to 0 you can use to obtain value of MA. But how to take, where to take, that's up to you. But you just give me the answer of MA, because I have solved this completely and I have answer also, so I can help you out in this, whether you are right or not, because this is the common exercise will be seen to be performed by every one of you in case when you want to develop complete diagram. So once you have one unknown moment, then it becomes very easy for you to calculate other moments. So I'm just writing, meanwhile you are working on that, meanwhile I'm writing the important points. This is point A, this is point B, this is point C, this is point D, and there will be some point of E also, right? So I will be requiring all these moments to be worked out by you people only. I have helped you to the critical point, right? This was the critical point to obtain the reaction. So I have given you the solution. Now it's your turn. So you work upon first of all MA and give me the answer. Take your time, 2 or 3 minutes maximum. I'll be eagerly waiting for your answer. Once you are done, you can, as usual, raise your hand. It's very easy for you, according to me, since you are a good students of mechanics of solids, so you know how to solve this problem. Yes, Birendra has raised the hand, So let me go to him. Okay, Virendra, unmute yourself.
Yes, sir. I am getting 39.94.
Exactly. So that is the correct answer for MA, 39.94 kilonewton into meter. That is the value of MA. So very good, Birendra. Now, who will give me the answer of moment at D? I hope everybody has understood how the MA can be worked out. For those still are not clear, let me give you tricks like you can take moment of all the forces about point C, or you may take moment of all the forces about point A, because anyhow MA is externally applied moment, so it will be there in your equation. If you take moment of all forces about point A also, you have to include MA, or if you take moment of all forces about point C, again you have to include every force over here. So there is nothing wrong to take any of the point like 8A, B and C. You can take moment of all the forces about any 3 points A, B and C. Right? So this is how you can work out. In my case, I have taken moment at point C. You can see here, I have taken moment at point C, right? I have the answer, but I'm just interested to know how you can work out well. So now give me the answer of MD. MD you have to answer me on left hand side as well as right hand side. So give me the answer of MD now. Take your time, 2-3 minutes. With your help today, we want to complete this numerical so that you can also have a confidence that you can solve any type of problem as far as this beam and energy principle number 2 is concerned. So again waiting for result of MD. Probably some new voice should come forward, right? Because those are working. Some other people should come. We have many students joined this session, like some of the names I can see here in this box itself. We have Happy, we have Vivek, we have Gaurav, and all. I mean, many students are there. Tilak, Dhaval, Vinay, Yangzong, many students are there. So I advise that you come forward. Why don't you try? Right? Albert is there. Henry has already responded once. Birendra has also tried. Stephen has answered. Prashant is there. Somebody has raised the hand. Let me go back to the Prashant and Birendra. Birendra will give will chance to Prashant. Yes, Prashant.
The 45.02 kilonewton meter.
You are right, dear. 45.02. That is correct. But according to our sign convention, what it should be like? Are you talking about on left hand side or right hand side?
The left hand side.
Left hand side. So then you should rethink about it. Don't you
Negative.
think? What it should be like? What sign should be there?
Negative.
Clockwise or anti-clockwise?
Clockwise.
Yes, clockwise. That is my point. Is so it should be negative. That's it, right? According to our understanding, according to our sign conventions, generally we follow that we follow clockwise as negative. So it is clockwise. So we should mention it negative on left hand side. But when the moment you go on the right hand side of point D, it will become anti-clockwise, so it is balanced. That's fine, but you did well, so that's fine. You can mute yourself and Now, of course, who will tell me about MB now? I need an answer for MB. Moment at B. Again, left hand side, right hand side. New face, new voice is expected from. See, it is just a calculation, nothing else. Why all are so hesitated, or why you don't bring your writing tools with you when our numerical sessions are going on? Theory, I can understand where you don't have larger role to play except the discussion. But in calculation, you should bring your calculators, you should bring your notepads with you, keep them with you, and keep doing the things. It gives you a feeling of appearing in the classroom. Otherwise it has no meaning. Watching and reading the numerical is something I don't understand, right? So you have to do it in your notes along with me. Whether you are successful or not, that is a different story, but at least you should make it possible to calculate, put the things on the paper. As far as the numericals are concerned, that is the right way to attend the numerical sessions. So Prashant, you already has responded. So let me wait for somebody else. Birendra has also answered. I need some new voices now. So I appreciate your efforts, but let's wait for one more minute. Otherwise, I will again keep the platform free to everyone. Birendra, okay, you already have answered it. So let me wait for somebody else for a moment. I'm giving you one more minute. If someone who has not yet, you know, discussed, anyone from other people, right? Try it. There's nothing wrong in that. MB, again, you take section at point B. Either you go for left hand side or right hand side. That's all. If you go on right hand side, you have all the values with you. If you go on left hand side, you have all the values with you. So the answer will be same on both sides, but the signs will be different. So we consider clockwise negative, anti-clockwise positive. That's the only thing you have to remember. What's a big deal? What's a big deal? Right? So anybody who has not yet discussed or answered anything, I need a new face to come into the picture. Anyone who has not answered yet, quickly make it fast. And it is up to your choice to appear in this discussion. However, I don't force, but please try to get connected yourself with the answers. Otherwise, we'll go to Birendra in a moment. So, anyone else would like to grab the opportunity? Any one of you? So, last chance, last minute. All right, anyone? Fine. Darsha, you also you also have answered earlier, so we'll need to wait for one more minute. I understand. The same story with Birendra also. So somebody else from the mass. Anyways, let's do one thing. Yes, Nipuna. Okay, what is the answer?
Sir, 70.02.
Very good, very good. So 70.02 kilonewton, as simple as that. So please tell us to what direction you are addressing, left hand side or right hand side? This answer is for left hand side or right hand side? Uh, yes, Biren and Raj.
Left hand side, sir.
Very good. It is left hand side, so it is positive. You can see here, and on obviously when you work on the right hand side, it will get turned into the negative value, right? So we started. You remember the discussion what we did here? Sorry, here in this slide, we discussed that we are very well expected that there will be some moment at point B, right? So that is what is the numerical confirmation we have received here. That definitely will be having some moment here, and that is 70.02. Now quickly give me the answer of last moment, that is ME. And again, some new face should come into picture as usual. Who will give me this value of ME? There is a big challenge to calculate ME because it is not that simple. Because, are you getting my point? I have not given the specified distance yet. Where you will take moment. Right? So that is the crux of this numerical, friends. How to get this location is the crux of this exercise. So friends, for that, let me simplify your confusion. You need to first develop your, yes, your shear force diagram. Okay, so let me help you out in that case. Let us draw your shear force diagram here. So this is again, I would like to write the values. Here you have 21.24. Here you have 100 point. How much? What was the value here? 100.43. Yes, and here it was 48.33. All right, friends. So let me start with the shear force diagram. First of all, let us say this is 21 itself, 24. Now somewhere in between we have downward force which is acting in the middle of this. So till here we'll be going straight with this value till here. So now since you have 50 over here at a red point, at this point, point D. So 50 is larger than 21.24, so we'll be going down, right? 50 minus 21.24 will give you 28.76. I hope you are doing with me in your notes, right? So from here, we don't have any load variation, so we'll be continuing with this till here, and here we have 100.43, that is going up, so that is positive, this guy is negative, so we'll be deducting 28.76 out of 100.43. So beyond this, we have to reach into the upper side because the answer will be positive definitely, and that answer will be nothing more than 71.67, right? So it will be 71.67 because you have to deduce this 28.76 out of 100.43. So answer will be positive, so we are going up, and now UDL is there. So go for a UDL, and 71.67 minus 120, isn't it? Because 20 is the load and 6 meter is the span, so 6 into 20, as simple as that, minus 71.67. When you do, you reach to this answer, that is 48.33, but your answer will be negative, so you have to come down here somewhere. I will subtend this and try to join these two lines together. So somewhere here you have a point of contraflexure or point of zero shear, and here the answer will be 48.33, but it is negative. However, we have positive value for us waiting over here, so it will be 0 here. Now to answer this question, that what will be the E value, I mean ME, you need these distances. That's why I keep it as straightforward as it is. Here it is x, and this is 6 minus x. So you know the very well trick of comparing the triangles with each other. Like x, in denominator you have this component 71.67, sorry, 71.67 equals to 6 minus x upon 48.33. So when you simplify this, you will be getting x value equals to 3.58 meters from where? From B, right? because you can see here this is the B point, this is A point, and this is C point. So now we have got this distance, and now I'm happy to tell you that now you can work out the value of ME easily. So now I'm waiting for ME again. I will be writing it here, ME. Now I again ask you to calculate ME and give me quickly the answer, so that we can finish the development of the BM diagram also. I have shown you the logic, I have given you the answer, so you can right now tell me what is ME moment. So we have MA done, we have MB done. Both are positive. You can see here on the left hand side, both are positive. While the span moments are, you know, on the left hand side, MB, it is 70 negative. On the right hand side, it is positive. So give me the value of ME and raise your hand once you are done, so that I know it is little lengthy, but again I'm sure that you guys can manage it. So it's nice interaction which I can guess, and this is the best way of doing the numericals at online platform, where students are also participating, they are also calculating, they are also actively involved in calculation. So take your one more 2 minutes and give me the answer once you are ready with your answer of ME, moment at E. And needless to add that that would be the point of maximum sagging moment. So there will be a positive moment at that location. At MD also we can expect some positive moment, and rest of the moments are at joints, so they will be negative. So we'll be drawing the diagrams negative, negative and positive, positive. I'll show you how to do it. Since the support moments are always negative, so you have to go for it accordingly. And span moments are largely positive because there is a sagging. And in joints, there is a hogging. So hogging will be shown below the line, sagging will be shown above the line with respect to the type of the loading. So that will come to immediately to the next step once I receive the value of ME. So we are reaching to the tick tick time. So we have only few minutes left with us. So please do it as fast as possible. See, unless if we interact like this, if we raise the questions logical sequences like this, there is no meaning of studying, structural analysis. As I give you the solution, right? Solution is available in textbook also, but there is no other person who can talk to you, who can ask you the doubts, who can interact with you, right, like this. So unless you communicate, it has of no use. And unfortunately this writing pad doesn't work properly in the classroom, so I'm still restricting myself going into the classrooms also. So you need to bear with me for a while until I develop some provisions. And we have Mr. Yadav with us. So yes, Prashant, tell us.
Sir, 44.86 from right hand side.
Sorry, come again.
44.86.
40.40.
44.86.
44.86. Okay. Well, I have a different answer over here with me. So let's wait for somebody else to confirm this answer.
Okay, sir.
Right. So we'll wait for some more answers from mass. Those who are already working with pen and paper and calculators. Birendra is there. Okay. Yes,
Yes,
Birendra.
sir. Sir, I am getting 58.39 from left side.
Very good. 58.39.
39.
So that's matching with my answer because I have already, as you know, I have already worked it out. Here you can see it is already there. ME, it is 58.37 in my case, but that's fine. Last figure is little differing. So, okay, Prashant, I think you just need to recheck it in case if something is missed out. So you can focus over there. And however, it is the main answer of ME that we have obtained, that is 58.37 in my case, right? So now it is positive, so it is support moment. So when you are, I mean, it is anti-clockwise. So now let me quickly show you how to develop the BM diagram. I will remove these things from the screen. So when you are developing the bending moment diagram, largely you just need to focus on basically on the behavior of the beam. So let me show you how it works. So here it goes like this. Here I will subtend the necessary other locations. We have MD, here we have the boundaries. This is the external boundary here. This is where we are expecting X, right? So ME location will be here somewhere. Okay. So let me write down A, then this would be B, this would be C, this would be D again, and here you have E. Okay. Now we have support moments, so they are always the support moments are always hogging, so we'll be showing them below the line, right? So at MA, that is 39.94. At B again I will be going down. So what is B? MB value, that is 70. So I need to go little more below than that. So that is 70.02. Now I know that at C it is 0, right? So I know this behavior of the UDL, and I've just now calculated the ME value also, that is the span moment, supposed to be the span moment. And since there is a UDL, so I will be connecting them with a parabolic curve. It's very difficult for me to draw the parabola in a correct curvature line, but assume that this is curvature. Please assume that it is curvature. Okay, so that is parabola, and here point load is there, so I will be connecting them with the straight lines. By the way, I just forgot to write, sorry, it's not the appropriate line here yet. Here I just first need to show the maximum value and then I need to connect it. Yes, so this is how it goes, like this. If we would have constructed the scaled diagram, it would have been perfect, right? But this is, I just wanted to show you, this is the again point of contraflexure which is developed. Here it is the zero shear moment, so that is maximum value, that is 58.39 here. This is positive. Now I have to connect these points straight away. MD value is 45.02, and again I will connect these 2 points like this with a straight line, with a straight line. So please pardon me, or apologies for not developing attractive diagram, but it is worth for explanation. Let me try last time to make a straight line. I'm sure it's very going to be very challenging and difficult for me, but let me try it. Okay, better than the earlier. So this is a straight line, this is also a straight line, don't take it as curve. Here it is curvature completely because of the UDL that we have, and this is how we have connected with the maximum value and the another value of this side. So friends, now we can say very well that we have developed the required diagram for bending moment diagram, for shear force diagram for the given problem. So with this, I would like to stop here, and in this next session, I will be taking you to the another journey of analyzing the trusses with the help of energy principle number 2, right? So we'll be analyzing trusses, and if possible, we'll take some one example on bent cantilevers also like this, and then we will try to solve one numerical on truss, just to give you an idea about the versatility of this energy principle in solution. Like, we'll be analyzing indeterminate trusses in the next class, right? So we'll try to do it, and we'll try to find out the forces and reactions like that. So thanks for joining. Stay safe, and take good care of yourself, and keep learning. Please bring your writing tools always with you when we have a structural analysis class, right? So those who have responded, participated, a big thank you to all of them, and I inspire others to participate like this. So thank you very much for joining.